Year 13 short revision video number 23. So we have some sort of question about trigonometry here and transformations of graphs. Part 1, sketch the graphs of y equals 4 cos x and y equals 2 sin x. Notice that x is between 0 and 180 and our sketch should be on the same coordinate axes. You can, of course, use your graphical calculator here to check your work or just verify that you are correct in your sketch work. So y, 0 and x, and let's put some key marker points in, 90 and 180. So 4 cos x is a stretched cosine graph, which we'll start here rather than at 1, we'll start at 4. We'll go down to 0 at 90 degrees, and then at 180 degrees, it will go down to -4. So our cosine curve will look a little bit like this. Now, the sine graph is y equals 2 sin x. So it will start at 0, 0. At 90 degrees, it will go up to 2 on the y-axis. And then 180 degrees, it will go back down to 0. So the curve will look like this. So, part 2. Find the exact coordinates of the point of intersection of these graphs, giving your answer in the form arctan A k root b. So we're looking at this point here where the two graphs intersect, where 4 cos x is equal to 2 sin x. So rearranging this, divide both sides by 2, divide both sides by cos x, we immediately get this result. So tan x is equal to 2, x is equal to arctan of 2. And of course we have to find the y-coordinate as well. Now, there are different ways in which we can do that. We need to be able to give this in an exact form. So if I sketch a quick diagram, if this is our angle x, let's say, tan of x is equal to 2, which means the ratio of the opposite to the adjacent must be 2. So the opposite can be 2 and the adjacent can be 1. And then with Pythagoras' theorem, we can work out that 2 squared plus 1 squared is 5. So the hypotenuse has got to be the square root of 5. Now, the y-coordinate can be worked out by substituting into this equation or this equation. So we just have to work out what 4 times the cos of x or 2 times the sine of x is. So y is equal to 4 times the cosine of x, which is clearly 1 over root 5. So that's 4 over root 5. Or if we use y equals 2 sin x, well, that's 2 times 2 over root 5, which also comes to 4 over root 5. So that just verifies our result there. We need to rationalise the denominator, so 4 root 5 over 5, and we have our coordinate of our point of intersection, which is at arctan 2, and then 4 root 5 over 5. Now, part 3 of the question. A student argues that without the condition x lies between 0 and 180, all the points of intersection of the graphs would occur at intervals of 360 because both sin x and cos x are periodic functions with this period. So comment on the validity of the argument. So the student is basically saying that because sine and cosine repeat themselves over a period of 360 degrees, they'll intersect every 360 degrees. However, that's not going to be the case because tan is involved in this point of intersection, and tan has a period of 180 degrees, so that argument is invalid for that reason.